All right, here we go. This video is going to be on anti-diff and integration. There are two things that I would say at a year 11 level you at least need to have seen the symbols, and then you can learn it in detail in year 12. It is part of the study designed, but you can always learn it in year 12 as well if you didn't pick it up in year 11. Okay, but here we go. All you need to learn, first part, anti-differentiation. Obviously, this means the opposite of differentiation. Now, notice here it says that it's the anti-diff, exercise 17E, for those who are interested. It's polynomial functions. So essentially, you've learned how to derive polynomial functions, which is your power rule. Okay, so x to the power 3, x to the power 4, x to the power of anything, right? That was your power rule. So then what you see here right now is the rule for the inverse of that, or the opposite of that. So here's an example. I'm going to show you an example, and you can see how the rule comes about. Say you got y equals to, 3x squared. Okay? Is that going to be work? Yeah, it should be all right. 3x squared. If I asked you to find the derivative, okay, so I'm going to do the derivative here, delta y, delta x, using power rule. Let's see what we remember. What is the derivative of 3x squared? Let's go with Max. Very good. 6x. So you got 3 there. Bring down the 2. And then it's x to the power of 2 minus 1. And yes, you're correct. That is 6x to the power of 1, which gives you 6x. Okay? Now, what you see in that step there, where you minus the power by 1 and you multiplied it by 2, or the coefficient 3, now when you're doing antidiff, you're actually now just doing the reverse of that. So going from 6x, I want to take 6x back to 3x squared. Okay? So the question is, right now the power is 1. How do I change a power of 1? So I'm going to highlight it. Power of 1, I want to bring it back to 2, logically. Okay, so the rule was 2 minus 1. So here's the 2 minus 1. That's how you got to 1. So if you want to go backwards now, instead of minusing 1, what would you do here? 1 plus 1. Makes sense. That's why in the rule, it has n plus 1. Okay, so actually you can figure this out. If you know how to do it, power rule, then you can go backwards as well. It's then add 1. So if I add 1 to it, well, that works out. 2 to the x to the power of 1 plus the 1. That will give me the 2. Great. But I don't want the 6. I need a 3. How did I get the 6? Well, I got the 6 by doing 3, which is the coefficient, times the 2. Okay, so where did I get that times 2 from? This is key. Where did times 2 come from? That was my original power. That's where the 2 came from. So in 6x to the power of 1, I don't have the 2. But I know that if I added the power, 1 plus 1, I will get that 2. Okay, so instead of timesing by 2, the opposite of timesing 2 is then dividing by 2. But how did I get 2? 1 plus the 1 is where I got the 2 from. That's the original power. That is why the rule down here says divided by n plus 1. That's only because you multiplied by whatever the power was. And so the opposite of multiplying is then divide. How do you get the original power? Or whatever your current power is, add 1. Okay, so that's where it comes from. And then obviously, well, what about this 3? Technically, the rule should be this. This should be your rule. Integration of ax to the power of n dx is equal to a multiplied to x to the power of n plus 1 over n plus 1. Okay? So it means that whatever the coefficient was, it's still there. So if I had that an extra coefficient to begin with, then it should still be there. So this is why I am meant to have this number 6. 6 is meant to be there. And if I put it all together now, you can see 6x to the power of 1 plus 1 over 1 plus 1. It works out to be 6x squared over 2, which simplifies it down to 3x squared. That's how you use that rule. So this is called, I'm going to give it a name. It's not that I'm giving it a name, but it's It's called indefinite integrals. So that's the first thing that you need to know for year 11, knowing how to use the anti-diff rule. Notice my answer in the rule, it has this plus C. In the exam, if you don't put a plus C and they asked you for the antiderivative, okay, the antiderivative, then you would get it wrong. Okay, so this is an indefinite integral. That's your answer there. It has to have that plus C. Why does it have the plus C? You might ask. This is why. If I gave you a couple of more examples, 3x squared plus 2, 3x squared minus 5. If I asked you to find the derivative for each one right now, delta y, delta x, delta y, delta x, what does it equal to in each and every one of them? 6x. See, the derivative of 2 is 0, and the derivative of 3x squared is still 6x, and this is still 6x. So the problem is, if I decide to do the antiderivative, which makes it go backwards, when I antiderive 6x, which we already just did, how do I know which one's the correct answer? Is it 3x squared plus 2? Is it 3x squared minus 5? Or is it just 3x squared? Which one is the correct answer? Because the derivative is always going to be 6x, 6x, 6x. So that's why when you do the antiderivative, you have to write the plus C, because we don't know what the C is. Okay, so at this point, you don't have, it's like finding the derivative function, but you don't know what the gradient is. The only way to know the gradient is if they give you a point. Same thing here in indefinite integrals, you are just finding the integration rule. That's what it is. Okay? So, let's practice the rule now. This is your chance. This is exercise 17E, and in your worksheets, that's what I'm getting you to train. So the first part is to work with indefinite integrals. So you're finding the antiderivative. Let's try this one. Here's the symbol. When you're writing this in your notation, I want you to have that summation notation. So antiderive 3x to the power of 5. And don't be lazy. You have to write dx. Later, normally I describe this to you, but because we're in a sort of a rush lesson, you're just going to have to do that. Okay? Zach, is that a question, or are you just putting up your finger?
So I have you for a week next week soon because the schedules are out. If I have it for Mads next year, can I just not turn up on Friday?
Well, one, you might not have me next year, but two,
it's my only period on Friday, and it's period 3.
I don't care. I expect the best of you. In fact, I do want to talk to you later about you choosing methods too. I don't care. I need commitment.
I know.
All right, here we go. Let's do the antiderivative. So I want you to have the symbol 3x to the power 5. Make sure to have dx. That actually just means change in x. In theoretical component, that makes sense as to why you're finding the area under the curve, which we'll talk about soon, okay? But let's just use the rule so far. So the rule says, remember, if you have a, so antiderivative a, x to the power of n dx, then this is equal to a times x to the power of n plus 1 over n plus 1. Don't forget plus c. That's my rule. So according to this rule, I will still have the 3 times x to the power of 5 plus 1 divided by 5 plus 1. Don't forget the plus c. Together, that now gives you 3x to the power of 6 over 6 plus c, which simplifies to x to the power of 6 on 2. Because 3 goes in 3 once, and 3 goes in 6 twice. Okay? That's just practicing the antiderivative rule. So when you're working through that worksheet that I printed out for you, that's all they're trying to get you to do. Okay? The later questions start to get you to get more involved with using antiderivatives. Okay? So you can have a look at this question here. Same idea. Let's say, how do we do example 25? Example 25. Notice I'm using a capital F for the function. I know the derivative gives me x cubed plus 4x squared. Okay, so the derivative of whatever this function is, I don't know, but it gives me this. What we're doing here is we're trying to find what the original function was. We know that we can antiderive to go back. So I'm going to now antiderive x cubed plus 4x squared dx. Okay, now remember, when you're doing this question, how do you find c? The only way to get c is they have to give you a coordinate. Okay, so in this case, x is 0, y is 0. So to answer this question, again, you're going back to your antiderivative rules. Here we go. Antiderive of x cubed, x to the power 3 plus 1 over 3 plus 1, plus 4 stays the same, 2 plus 1 over 2 plus 1, don't forget plus c. You can see here now, x to the power 4 over 4, 4 over 3, x cubed, plus c. This is your f of x. This is your function. I'm going to write with a capital F. That's your function. But the only way to find c now, how do you find c? Because they want you to find f of x. Find c, they gave you this piece of information, and they said f of 0 equals 0. Okay, so this is where you can substitute in f of 0 equals to 0 to the power of 4 on 4 plus 4, 0 cubed over 3 plus c, and conveniently that gives you c equals to 0. Okay, so there are two types of questions there to do with indefinite integrals, and that's what you're learning. One, how to use the rule. Two, how would you find c? Okay, so when you find indefinite integrals, you don't have c. That's the first part of the exercise. Okay, so as you're doing these questions here, that's what they want you to do. Okay, now, if you flip over to the back of the page, this is your second skill. So you had indefinite integrals, and the last thing that I want to at least introduce to you, and there's a video here for you to watch later on, definite integrals. This is your last part. Now, normally I teach this probably over a week to ensure that you have an understanding of what it is. I encourage you during the holidays to watch Khan Academy if you want to know the theory behind it and understand what it's actually doing. Otherwise, you can just watch this video and it teaches you how to do it. Okay? Definite integral talks about, it's like your differentiation. You found the gradient function, and then to find the gradient, you have to sub in a value, right? Same thing with this one. Antidiff. What's the point of antidiff? It actually finds the area under any particular curve, and to find that value, you need an interval. Okay, so here's an example. If you had a quadratic graph, say it looks like this. So f of x is equal to x squared. If I said antiderive x squared dx, that only gives you the area function. It doesn't actually tell you what the area is. Kind of like if you derive, it doesn't tell you the gradient until you have a point, right? So to find the area under a curve, I can say between 0 and say 1. The area under that curve can actually be solved antiderive x squared dx, but it's between the lower boundary, 0, to the upper boundary, 1. So if you look on the back of your sheet, each and every one of those antiderivative functions have an interval. Okay, so that's what the numbers mean. 0 to 1 or a to b. A is your lower boundary and b is your upper boundary. Okay? How do you solve this? This pulls onto the idea of fundamental theorem of calculus. Khan Academy. I want you to watch that over the holidays if you want to understand where it comes from. But Khan Academy explains why this is true. Okay, for those who aren't interested, you can just simply apply the rule. Okay, so how does the rule work? when you find the antiderivative, you get the original function, the intervals a and b, to find the value sub b in minus sub a. That's the fundamental theorem of calculus. Okay? So here's an example. If I were to solve this one, what is the area under the curve? Sorry, year 11s. I am recording. I don't want your voices to come through this. Thank you. So let's antiderive this now. So x squared, we know that using the rule, we've got x to the power of 2 plus 1 over 2 plus 1. That's just your rule. Now, normally you can put the plus c, but you'll find in definite integrals the plus c will cancel out. So I'm going to show you. So this is plus c. 0 to 1, using fundamental theorem of calculus. I'm going to write here fundamental theorem of calculus, FTC. The rule says here that you're doing sub b in minus sub a in. So that's what I'm going to do. I'm going to sub in 1 to the power of 3 divided by 3 minus sub 0 in. I'm using fundamental theorem of calculus there. So this is f of b minus f of a. Okay, so if you're interested to know why, you can substitute those in. Khan Academy explains that, but that's all you need to understand. So if I apply that now, you will see if I sub b in, which was now 1/3, okay, and I put the plus c in, I keep the plus c, minus 0 cubed is still 0 over 3 plus c, you'll see now this is 1/3 plus c minus 0 minus c, and the c's cancel out. That's why in definite integral we normally don't write the plus c, because we know it'll always cancel out. Okay, so yes, you're normally meant to have it when you antiderive, but we know in definite integrals, once you use fundamental theorem of calculus, the c's will always cancel out. Okay, and so that leaves us with 1/3 minus 0. This is the area under this curve. The area is equal to 1/3. Okay, and that literally summarizes what I normally teach for antiderivatives, indefinite integral and definite integrals. Next year, you'll be playing around with negative area and then net area as well, but you just need to know how to find definite integral. Okay, so first step is, how do you find indefinite integrals of polynomials? Number 2, how do you use fundamental theorem of calculus? And that's it for year 11. Okay, so practice that over the holidays. I do want you to have at least an idea before you walk into year 12 next year. I'm sure there's going to be some holiday homework for other things, but at least get your head around integration and antidiff. Okay, hope this video helps. I will make some more videos just on any of these problems here to guide you. Solutions for your worksheet that I've given out is here. Okay, so you can look at the solutions just to check if you're on the right track. They're all there for you to see the working method. How do you do definite integrals as well? Okay, and that marks our last lesson for methods. So thank you, everyone. I will make more videos just to help along, but you'll have access to it, and I hope that helps, especially during your holidays. Okay? All right, let's stop the video.